Hey guys, welcome back to my YouTube channel. So, under this lesson, we are going to look at the limit of a sequence and how to find the limit of a sequence. So, this is a short piece of notes I've drafted to help us understand sequences and its limits as easy as it can be. Okay, so when we say a sequence has a limit, what are we trying to say? Obviously, every sequence would have a limit in which this limit is going to be called L. Now, depending on the value of the L, we can determine whether the sequence is converging or is diverging. Now, the limit of a sequence is trying to actually tell us that a particular sequence will approach a certain value, but it won't get to that value, but it is going to approach that value. So if a sequence is converging, then it means the particular sequence is approaching a particular value, but it's not going to necessarily get to that value. And when we say a sequence is diverging, then it actually means a sequence is actually moving into the infinity range or the infinity column. So let's say when you find the limit of a sequence and your L or your output or your result is, let's say, a value like 4, this actually means the limit that your sequence can get to is going to approach 4, but it's not going to be 4 exactly. Please, let's understand something very carefully. The limit tells you the value that the sequence is going to approach. So it's like we human beings like this. We can say we are all approaching the future. So the future over here becomes our limit because every day becomes the future. Tomorrow like this is the future. God willing, if God gives us tomorrow, obviously we've gotten to the future. But there is going to be another tomorrow again. So you realize that we are always approaching the future, but we are not getting to the future. You always get to another day, there's another day. You always get to another day, there is another day. So the future over here becomes our limit, and we, the human beings, are approaching it. So every day we get a new day, every day we get a new day. So that's just an analogy I decided to bring it in to help you guys understand it as it can be. So let's move on. So as I said, a sequence will converge when it approaches a particular value or when the L value of that particular sequence exists. So let's say when you get an integer, right? When you get an integer, automatically you are trying to understand that the sequence is going to converge. But when you get anything like um infinity, positive infinity, negative infinity, it means there is no particular point in which this sequence is going to approach to, because infinity means you are going forever and ever. And human beings too don't diverge, we always converge to the future until we are no more. Okay, so I've decided to draft this information into the theorems I constructed myself. So these theorems are not exactly as you think maybe they are or drafted, but I decided to make them in this way to make things very, very, very easier. So let's look at the first theorem. So the first theorem says when you take the limit, of of an expression like this, so let's say 1 over n, as n is approaching infinity. So we always take the limits majority of the times when n is approaching infinity. Now it says when you have 1 over n exponent r. Now, anytime we take the limit of something like this, it's going to automatically go to 0. Now, let's understand why. Now, the limit of this function as n approaches infinity means wherever we see n, we are going to input infinity over here. Now, you take a look at this scenario. When you have one orange and you divide it amongst your two children, obviously everyone is going to get half each, right? What if you divide this same one orange between or amongst 5 children? What's going to happen? It's going to keep on getting smaller and smaller. So imagine you trying to divide one orange amongst 1,000 people. Imagine you trying to divide one orange amongst 10,000 people. You realize that the value is keep on going to get smaller and smaller until it gets to 0. But remember, it's going to approach 0, but it's not going to be 0, because no matter how you divide, you are still going to get a piece of that orange. Yes, so that's where this theorem came from. So you know that 1 over any power of n raised to the power r, as long as r is greater than 0. So as I gave an example over here, the limit as n approaches infinity of one exponent n is going to give us 0. The same thing to applies over here. So anytime you have what, a variable with an exponent greater than 0, automatically is going to give you a limit approaching what, 0. Yes, this should be a very common concept you should what, grasp. Now let's look at the theorem 2. Now with this theorem, we are trying to look at the limit laws. So let's say we have two sequences. We have the first sequence, which is a sub n, and we also have the second sequence, which is b sub n. And we are trying to understand something, so obviously they are all convergent. And we also have a c, which is a constant. How can we apply the limit laws in case we find a problem like this? So when we look at the first one, it says that anytime you have a limit of two sequence adding or subtracting. Now you see these ones, they are in a what? They are in a bracket. Now anytime you have a limit of two different sequence adding or subtracting, you don't just add them and find their what? Their limits. Rather, what do? You distribute the limits towards each subsequent what sequence. So you find the limit of the first sequence, you find the limit of the second sequence, then you now add or subtract their results. The same thing happens for multiplication, the same thing happens for division. Yes. So anytime you are dividing, of course, you find the limit of the numerator, you find the limit of the denominator, then you will obviously solve. Now, when you look at this theorem, we also have another theorem over here, or it's also part of the limit laws. Now, it says anytime you are trying to find the limit of a sequence raised to a certain power, what do? All you have to do is find the limit of that particular sequence. After finding the limit of that particular sequence, then you raise it to the power. Once that power is greater than 0, which means to the power 1, to the power 2, to the power 3, and so on and so forth. Now, the next one too is saying that what, when you have a limit of a sequence with a constant. Now, you know that the limit of a constant is always going to give you the same constant. So when you are being told to find the limit of 6, there is nowhere you can input n as infinity into 6, because 6 is just a number. So the limit of every constant is equal to the same constant. So with that theory, we know that anytime you're having a constant in a sequence, what do? You always what, bring the constant outside and find the limit of the actual sequence. So you realize we have a limit of c and what, an. Now the c is the constant, so the constant comes out and we have the actual sequence over there. Now another sequence or another theorem we are going to talk about is the squeeze theorem. For this one, I wouldn't talk much about this, but we'll get to learn them when we begin to solve some examples. The squeeze theorem is basically like finding two separate sequences for which, if their limit converges to a particular value, of course the actual sequence is also going to converge. As I said, I don't want to really explain this one into details right now, because when we get forward we will know how to solve them. Now the next theorem is also telling us that what, anytime you find the limit of the absolute value of a particular sequence and it gives you 0, then it means that particular sequence is also going to give you 0. So you might have a sequence which might consist negative ones, those alternators, as we spoke about in our previous videos. When you take their absolute value and the final limit you are getting is approaching 0, then it means the actual limit is also going to approach what, 0. Now the next one too is also telling us that what, if you have a limit of a function, right? You have a limit which approaches L, and the function f is continuous at L, then of course you can find the limits by saying that the function and both the what, the one that you had with the new function are going to be the same. As I said, with this one too, I would also explain it into details when we are solving. Yes. So we are now getting towards the latter part of the video. After that, we solve some examples. Now the last one is also saying that what, anytime you have a limit of what, of a sequence. Now with this one, we are having r exponent n. It says what, when r is less than -1 and greater than 1, which means when r is a fraction, obviously your limit is going to approach 0. Anytime your r is a fraction, you are going to always approach what, 0. And also, when your r is equal to 1, obviously your limit is also going to what? Approach what? 1. Yes, and the last theorem that we are also going to talk about, not the last, but anytime you find the limit of polynomials, all the limits of polynomials are going to result to infinity. Yes, all the limits of polynomials are going to result to infinity. So, for example, we have 4n squared plus 3n plus 2 is equal to what? Infinity. Because obviously, when you find the limit of this one, the highest power is going to go to infinity. And when you add the rest, automatically everything is going to go to infinity. Now, let's look at how to solve or how to find the limit of certain sequences.